The 12-fan Wall of Wind facility at FIU, which we call the WOW, is the largest and most powerful hurricane simulation facility in a university setting that can simulate Category 5 hurricane wind, the highest rating on the Saffir-Simpson hurricane scale.
The Wall of Wind allows for wind loading experiments on various structures at multiple scales. And because it is an open jet facility, it is capable of doing destructive testing on structures to study their failure and collapse modes without the risk of damaging the wind tunnel. The Wall of Wind can do holistic system level testing. That means we can test structures with the components and connections as integral part of those structures and study the system level performance. We can also look at wind-driven rain intrusion into actual building envelope, and we can study progressive damage of the system. So this is a new way of looking at hurricane impacts on building systems, because building envelopes are one of the most vulnerable elements in hurricanes.
Here in the control room for the Wall of Wind, we can monitor a lot of the systems that are part of the Wall of Wind, but we can also control them. We can control our pressure scanning systems, wind speed measurement devices, load cells, force balances, transducers, and a lot of many other instruments that we have available in this facility. We also have a system with high definition cameras that we can see over here and record when a part of the model failed and how it fails.
Our safety program includes personnel safety, which includes trainings through the Environmental Health and Safety Department within Florida International University. Also includes safety protocol to ensure the safety of all equipment within the Wall of Wind.
The Wall of Wind is a very versatile wind testing facility. It can test up to speeds that are equivalent to Category 5 hurricane speeds, 160 miles an hour. And it also simulates the wind profile and turbulence of natural winds very well. So we have already tested and will continue to test a wide variety of different research projects in this facility. For example, we have tested full-scale systems for roofing, like standing seam metal roofs, roof paving systems, tiles, shingles, and so on. Those can be tested essentially at full scale, and it allows us to look at the way the whole system performs under wind loading, as well as its interaction with the wind loading. So that's a very important role of this facility. We also have been developing techniques that are applicable to smaller structures, which we call partial turbulence simulation, which allows us to put relatively large-scale models in the facility, and we combine the test data with other analysis and computational methods to give us predictions that include all the big-scale turbulence that we may not be able to include at that scale in this facility. We've done testing related to the transportation industry. One example would be variable message signs. We've done a project here with a PhD student whereby we've refined the aerodynamic coefficients used in the AASHTO code and the gust factors, and we've looked at the phenomena of vortex shedding and galloping, which could cause vibrations of these structures at high wind speeds. That's another example of the application of this kind of facility.
One of the most important aspects of wind engineering research is related to codification of research findings. So here at the Wall of Wind, we test small, large and full-scale models in order to extract those important information that we can use in order to enhance current building codes and wind standards. The codification process in these type of studies has a direct impact on people's safety and economic development of our community.
So the STEM Transformation Institute makes use of this classroom to allow students to learn about their sciences in the classroom as scientists. In this case, this is a bridge between the Wall of Wind and students learning in the classroom. So it brings the Wall of Wind straight into this classroom where students are going to learn about it through this active learning process.
Wall of Wind was used to develop and validate various innovative mitigation techniques for lessening hurricane impacts on structures. One example is the validation of aero edge, which are edge devices that can be put on roof to reduce the wind uplift damage on roof components. This product was developed by the industry partner of the Wall of Wind and has been patented. Wall of Wind has proved to be a multi-user research infrastructure both for national and international researchers.
The vision of the Wall of Wind facility is to significantly advance the state-of-the-art in wind engineering research and education, and to impart resiliency and sustainability to new and existing buildings, cladding systems, and lifeline infrastructure so as to prevent wind hazards from becoming disasters.